Hi guys, welcome back. So today we're starting partial derivatives. Okay, so here you see an example. So here we are asked to find the partial derivative with respect to x and with respect to y. So before doing that, let me just recall what are the simple derivatives that you have been doing so far. Okay, so the derivative that you have been doing so far were in the form like x to the power of n, and how you would do the derivative of that. So you would bring the n down, so you put n and then you would subtract 1 from it, so n minus 1, right? And so let's do an example. So x to the power of 4, what would be the derivative of this? So 5x to the power of 4, right? Because x to the power of 5, the derivative of this is 5x to the power of 4, because you bring the f down and subtract 1 from it. Okay, then similarly y to the power of 8y7, right? The derivative of this. And the derivative of 2x, what is it? 2, because this 2 is to the power of 1, and if you do 1 minus 1, so that will become x to the power of 0. And what is x to the power of 0? Anything to the power of 0 is simply 1, so you just write 2. And what's the derivative of x? It's simply 1, like I just explained. X to the power of 0 is 1, and 2w to the power of 3, so 6w squared. Okay, so I guess that this is it for the review. Let's get back to the partial derivatives now. Okay, so here, so partial derivatives is simply functions more than one variables. So here you see you have x and y. So before you would have a function like f of x equals to x to the power of 5 minus 4, a function like this, right? And you would simply take derivative like this, right? But in here, notice you have two variable function. So you would, since this function is in the form of y and x, so here this function can also be written as f of xy is equals to x squared minus xy squared plus 4y to the power of 5. This, if you see z or you see f of xy, these are the same thing, because this is simply saying that the function is in two variables, x and y. Okay, so since this function is in two variables, x and y, so we have to differentiate this equation with respect to x and then with respect to y. So this, the fancy d that you see here, this just represents partial derivative. Okay, so this means that you're taking the partial derivative of the function z with respect to x. This can also be written as simply f of x, and here the partial derivative of z with respect to y can also be written as f of y. So like simply taking the function f and differentiating with respect to x and differentiating the function with respect to y. Okay, so now we will start it. So how do we do this? So here, to take the derivative with respect to x, you simply need to remember that here the y is constant. You always treat the y as constant when you're the other variable as a constant if you're differentiating with respect to one variable. Okay, so here in this case we're differentiating with respect to x, so the y is constant. Okay, so here since y is constant, so this is x to the power of 2, so then we just take it like before, 2x and then minus. So then what's the derivative of x? This is simply 1, and a y squared, it's just going to stay there. You do not differentiate it because you're treating y as a constant. Okay, and here you have y to the power of 5, and 4 is a constant as well, so you're treating the whole thing as a constant. And what's the derivative of a constant? It's 0, right? So this is simply the derivative with respect to x. Okay, now let's do with respect to y. So here again, remember I told you if you're differentiating with respect to one variable, then you treat the other one as a constant. So here in this case we're differentiating with respect to y, so we're treating x as a constant. Okay, so here this x is a constant, so what's the derivative of constant? Of course 0. And then differentiate y. So what's the derivative of y squared? It's 2y. And again, putting here the x because it's a constant, so you don't differentiate it. You just treat it like 2, right? You just put it there because it's a constant. And then what's the derivative of this? So there's no the constant is only 4 here, so you just do like you would do normally, the derivative. So 4 times 5, which is 20, and y to the power of 4, right? So this is the derivative with respect to y. And of course you can just write it neatly without writing the 0. Okay, so now let's do another example. Alright, so we have a different example here. So here it says that we have a function here, and so again notice that this function is in variable of 2, is a function of 2 variables, x and y. So how you would do differentiate this function? So you would need to find the f of x and f of y, or you can also write it like this, the derivative of z with respect to x, or the derivative of z with respect to y. Okay, so I'm just gonna keep the f of x and f of y since it's easier, you know, just like differentiating the function with respect to x and y. Okay, so first let's do with respect to x. So since we're differentiating with respect to x, what do? We keep y as a constant. Okay, keeping y as a constant, so you treat y to the power 3 just like 5. Okay, so you can just put them over here since these are constant. Now you can differentiate this x to the power of 4, so the 4 brings down, so it becomes 20, so you need to put a 20 here. Okay, so then 20 x to the power of 3. And now y is a constant, it stays there. Differentiate x squared, so this is 2x. The derivative of this is 30 x to the power of 4. And now this is a constant, this whole thing is a constant, 4 is a constant, y is a constant as well. The derivative of constant is 0. Okay, so just don't write it. Okay, so this is the derivative with respect to x. Okay, now let's find the derivative with respect to y. So treating x as a constant this time. Okay, so x is a constant, so just gonna write in here, just treat it as a constant. Now we're differentiating y, so 5 times 3, this is 15, and y, 3 minus 1, it's 2. Now we're differentiating y only, treating x as a constant, putting x here, and now only differentiating y, so 6 y 5 plus differentiating, keeping as x as a constant, so this whole thing becomes 0. And then since we're differentiating y, so negative 4. So this is the derivative with respect to y. Alright, let's do another problem. Alright, so this is the last example. So here notice we're again given x and y, so we're differentiating this function with respect to x and with respect to y. So here treating y as a constant, so differentiating x only. So differentiating x only means negative 3x squared plus y as a constant again, so 6y squared, and okay, so what's 6 times 2? 12. Wow. Okay, 12x, and then this whole thing is a constant, so 0, or you don't write it. Okay, now with respect to y, so treating x as a constant, so differentiating y only, so this is 0, and then plus so treating x as a constant, so x is a constant, so you simply put it here, and then differentiating y, so 6 times 3, this is 18, so 18y squared plus 5 times 2, that's 10 y. Okay, so this is the answer with respect to y, and this is the answer with respect to x. Okay, so that was it for today's video. I hope you find it helpful. Thanks for watching. Bye.